Okay, so here you have a question where we're trying to model a sine curve off of a year. And since it's dealing with days, we might as well convert the year into days. Sure, we could use 365.25 to accurately reflect it, but in this case, you don't really have to. What we're going to notice is that June 21st is the longest, or highest part of the curve, and that December 21st is the shortest. Now, they give us the highest. They tell us the highest is 15.7. And they give us the lowest, 8.3. And this is hours of daylight. So that means the x-axis is going to be the days of the year, and the y-axis is going to be hours of daylight. So now we know a max and a min. We just need to know the middle, and that's adding them. So you add them, you get 16 and 8 is 24, and divide by 2, 12, which means the axis is at 12 hours, days. Looking at the amplitude is going to be the max minus the axis. The max is 15.7 minus 12. That means we have an amplitude of 3.7. Now we also know that our period is 365. And normally it's 2 pi. So that means we have to multiply 2 pi by 365 and divide it by 2 pi. However, we will do the reverse of that in front of the x because it's always the reverse. I could divide the 2 into 365, but it's best to keep it as a whole fraction. The only thing left is horizontal translation. If we notice, if we pretend that December is at the very end, it's going to be the lowest way over here. It's also going to be the lowest just before this as the years repeat. And the highest, as it mentions, is June 21st, which is roughly, since June's the 6th month, it's going to be roughly in the middle. Which means we have one that is roughly low here. So it's going to come like this, and go up, and come like this. There's several ways you can do it. If you notice, this part here is like a cosine curve upside down, which could be possible. But this part here is also a sine curve that's adjusted to the right. Problem with this part here is this is supposed to be January 1st. This is supposed to be December 21st. So figuring out the distance between those in days is not too hard, but you would need to know how many days in the year are in December and the other months. Well, December is pretty straightforward because the 31st is always New Year's. So that means from 31 to 21 is 10 days. And January 1st is one more day. So we're talking about 11 days. So if we think of this as a cos curve upside down that we shift 11 days to the left, that's probably the easiest. To get a cos curve upside down, you have to put a reflection in the x-axis. So that means we put that in front of the amplitude. And then you also have to shift it to the left 11 days. So we're going to have to say plus 11 days. Looking at this, this should be the equation. This should bring the axis up to 12. This should give me the amplitude that I need. This should reflect it so the cos curve starts at the bottom. This should turn it into 365 days. And this should shift it 11 days to the left. Let's see if we got that right. My typing's a little off today. There we go. And now I just need to bring it up to where we can see it. Since the shortest is 8.3 and the longest is 15.7. This is what we should see. Now, the only thing that I have to be concerned about is if this is 11 days to the left. It is. So that's the shortest day, December 21st. And if this is the longest day. Now, notice that the longest day has a half unit. So that means we probably got it wrong by half a day. However, the big problem is if we're going to make this the peak of January 21st, we would have to figure out how to go backwards from January 21st, if that's going to be accurate. And then December 21st is no longer going to be the middle. So if we look here, 354 is 11 days short of the final date. So really, you're going to have a peak problem no matter what. And that's probably because we use 365 point instead of 0.25, but I doubt that'll solve it. It might. No, it doesn't. So you're either going to use this as a peak and then the minimum will be off by half a day, or you're going to use this as the min and then this will be off by half day. It's very hard to get both unless we change this to like 364 or something. Yeah, and then you get it. But as we know, there's not 364 days in the year. We can try shifting at 10. Oop, but I don't believe that'll work. Puts 10 short, and it still does the half day. So no matter what, you're not going to get the correct 21st day over here. Now, if we adjust it 10.5 instead, our peak will now be accurate with a nice even day, but our lowest day will always be off by half day. So again, there's no way around that unless you cheat the days, or if you maybe assume it's a leap year. If you assume it's a leap year, it works out great. So you can see you're going to have problems based on their information and your modeling, because 365 days does not break out, does not divide equally into 4 pieces. So no matter what, some of the information given will not be accurate. And just to see if they might give the equation, but just to see if it's the same equation in the back. Now, you can see that we got the amplitude correctly, 3.7. They use a sine curve, and they don't adjust it at all, which is interesting. But everything else we got right. So they don't reflect at all. So let's see what happens if we just do that with the sine curve. I don't think that's quite right anyway. I think what they did is yeah, that's not right at all. Yeah, I don't feel that's a good graph at all. Because this starting point is only 9 point, let's see, it's 91 away, and December should be the shortest. No, I don't feel this is good at all, unless they're counting the very beginning as not January 1st. Anyway, got all the other data points right. Going back to our model, they want to know what the temperature is on the January 30th, which is essentially the 30th day. So you can either slide it over here, or you can put in 30 for x and solve it algebraically, or you can just do on the graphic f of 30. And that will be how many hours on January 30th. Now, if you wanted to do it algebraically, you would just put in a 30 here, add it to 11, that's 41, multiply by 2 pi, divide by 365, find the cos of that, multiply it by negative 3.7, and then add 12. And that'll give you this number. I'm not going to bother because it's simple calculation. The city of Thunder Bay has an average monthly temperature between minus 14.8, that's the minimum, and 17.6, that's the highest. The following table gives the average monthly temperatures averaging over many years. Determine the equation of the sine function, so they want a sine curve, that describes the data, and use your equation to determine the times that the temperature is below 0. Okay. So this one can be broken down in months because they're not using, they're not asking for specific days. So if we're looking at a sine curve, it means the min is minus 14.8, which happens in January, which makes our starting point easier. Good question would be, is that the middle of January or the very beginning of January? We're going to just assume the very beginning. And the max point is 17.6, which happens in July. So numerically, that's interesting because July is the 7th month. So we're going to have to put it right in the beginning of both of these so that it's just 6 months apart. That means our period's going to be 12. So that means we have to multiply, normally multiply by 12 over 2 pi, but because it's the reverse, we're going to do 2 pi over 12, and then we're going to simplify pi over 6. So this should be our multiplier. And then since we're starting at the very bottom, let's figure out our amplitude. Is first our axis is min plus max divided by 2. So that's minus 14 plus 17, so minus 14.8. Another way to do this is 17.6 minus 14.8. We can see that that's going to be 3. And then minus 0.8 is going to be 2.8. Which means our amplitude is going to be max minus 2.8, which is 15 minus 0.8, which is 14.8. So now we have our period, our axis, and our amplitude. Now let's see if we have to adjust it horizontally. Since our January is going to be our bottom, and end of December is going to be our bottom again, it means our peak will take care of itself in July 1st. This is an upside down cos curve. It means I have to put a minus in front of the amplitude. Now, that's a cos curve, and they want us to use a sine curve. A sine curve, if it starts here and goes down, I think the easiest one is to do this one. And that means we're going to push it 1/4, just the way we do 90 degrees for any sine or cos curve. We're going to push it to the right 1/4 so that the sine curve starts here and goes down and up. And 1/4 of our current period is 12. Quarter of that is 4. To push to the right, we're going to add 4. Let's see if that's right. Now, ideally, I would just put a negative amplitude with a cos curve is the perfect solution. But for the sine curve, this is what we're going to have to do. And it won't be flipped because it's just pushed to the right. Sorry, minus 4 to push it to the right. That should be it for the sine curve. If we were going to do the cos curve, perfect. Personally, I think the cos curve is cleaner. Let's see if we get the same curves if we do it both ways. And if we can reflect our data. Okay. Just working out the bugs here. The reason it's doing that is because the x-axis is too big. We're going to make it 0, 12, steps of 1, And we're going to boost this up from minus 20 all the way up to 20, let's say. And that's our sine curve. And I can see I didn't quite get this done properly. 2π/12. Push it to the right. Oh. Sorry, it's not 4. A quarter of 12 is 3. So there we go. And that will make January 1st our lowest month up, but I can see there's another problem here because that's not the lowest of the month. So I did some calculation error somewhere. So if our lowest is minus 14.8 and that is our highest, I need to average the two max and mins. The amplitude is 1.4. I don't know where I got, or sorry, the axis is 1.4, which means my amplitude is going to be wrong as well, which means my amplitude is 16.2. Let's see if I got the bottom. 14.8. Yeah, and the top should be 17.6. Yep, there we go. Right in the, and it says June, and they want July. So that means I should be pushing everything further. One more. And that should be it. Yeah, that should be the end of January. And that's the beginning of, or the end of July. So the problem with these 12 things is, I mean, if I were to put it perfectly in the middle, it would be something like this. Let's see. This would be the middle of January, and this would be the middle of June. So you can't quite get it right no matter what. So you actually have to push it 4 over if you want 7 to represent July. But let's see if that other coast curve gives me the same thing. I have to move it 1. No, I shouldn't have to move it. Yeah, I have to move it 1, I think. There we go. It's the same curve. Bottom of the end of July is minus 14.8, and top of the end of January is 14.8, and end of July is 17.6. I mean, if this marks the end instead of the beginning, then yeah, it makes more sense. But technically, the first month ends at the end of January. Sort of a difficult interpretation. When is the temperature below 0? Okay, so there's 2 ways to go about this. Let's assume that this equation here is correct. And we're going to use the sine. First of all, since we know it's a sine that's slightly adjusted to the right, we know it's going to start here, go up, down, and up. We also know the axis is around 1.4, so 0 is going to be somewhere down here, which means it's going to happen before, and January's down here, so it's going to happen just before April. And generally speaking, it's going to happen, that's going to take 6 months. And it's going to happen again over there. So it's going to happen around 12 and onwards. But here's what you can do. So we know that it's the y. It's going to be 0. So let's just do it like this and just call it angle, sine of angle. Plus 1.4, subtract 1.4 from both sides. divide both sides by 16.2, and solve. So first find the sine of angle. Notice it's negative, and we know that sine is negative in quadrants 3 and 4, which means the answer in our calculator is going to be in quadrant 4. So let's figure what that out is in both degrees and in pi. So we're going to keep it in degrees first. And our first answer is this many degrees. Oh, it's going to give it in quadrant 4. And it's going to give this answer in radians. Also in negative radians. So that's a very small amount of radians. And 2 pi represents, so if we take 1 pi and added that, our second angle in quadrant 3, because this is clearly in quadrant 4, negative 0.88 in radians is here. That means it's going to be 0.8 acute angle here. And all we have to do is find pi plus that. And since negative 0.8 is in that quadrant, it's going to be 2 pi minus 0.086 minus that. And 1 pi plus that. And those are the two angles, because negative 0.0686527 is the acute angle, really. Which means we're going to work with these two angles. We might as well find them here. And put that in memory. And I'm just going to add 2 pi. So that's the quadrant 4 rather. And here is quadrant 3. So those are the two angles to work with. Which means this is going to be equal to either of those angles. So we'll just take that one first. That's multiplied by 6 and then divided by pi. There we go. Multiplied by 6, divided by pi, and add 4. So that's my first value of x when it's 0. And then my second value of x I have to multiply by 6, divide by pi, and add 4. Which my second answer is that. The question is, if I look at 15 and 10, is it going up or is it going down? So remember that it's a sine curve. It's starting a bit over here. It's going up. Also remember that we're supposed to go from 0 to 12, and it looks like I've found 15 and 10, which doesn't quite work. So it looks like I found these ones over here instead of this one over here. I'm going to assume this is a low point, and then here, and that 15 is way over there when it goes down again. So I should subtract 12 here. And we're talking 13, 12 rather, 3.83. So I'm going to say it's between 3.83 and 10. Let's see if that's true. And then we're going to put y is equal to 0. So sure enough, the green line represents y is equal to 0. The black line represents that 1 month that I found. And again, so it's actually not between these that below 0. It's after 10, so 10 to 12, and from 0 to 4. And yeah, I should have figured that out because I know it goes down and up in the beginning. So then you can figure out from 4 to 10 is the positive zone. So you just have to know what your graph looks like to figure out which value. So it's when it's x is smaller than 3.835 and when x is bigger than 10.125. Notice that 15 is still a valid answer. It just occurs over here. So I've accidentally figured out, this is why I don't like the sine curve, because quadrant 4 is over here, outside of my 12 range, when I should really be figuring out quadrant 1 again. Anyway, we did algebraically get the right answer, but then you have to use some logic to fit it within the proper period, and then you have to compare it to your image to figure out, are we above 0 past this point or below 0 past this point? And since we know that it's rising to higher temperatures, I should have figured out it's below 3.8 and above 10.165. The interesting one in this one is that we came up with 15.8347, which makes sense when you realize that our sine curve starts here and it ends over here because we adjusted it 4 to the right. So when I'm doing the algebra, it's finding it within what is technically my first period, which is this one over here. Would have been smarter to use a cos curve again instead, because the cos curve would have given us the proper periods within our first 12. And then we've got a nail stuck to the tire of a car. So you just have to remember that the tire of the car is on the outside, like this, and the nail would be stuck out here somewhere. If a student wants to graph a sine wave in the model, the height of the nail above the ground during a trip from Kingston, Ontario to Hamilton, should the student graph the distance of the nail above the ground as a function of time or as a function of total distance traveled by the nail? So do you want time on the y-axis or distance on the y-axis? And I would argue, or sorry, time on the x-axis or distance on the x-axis. I argue that it's going to be based on distance, because for it to be based on time, you're only going to get the first period, and then you have to figure out all the subsequent periods. Also, since we're talking about height, it should really, the height should be based on the distance traveled, I believe. It's a good question, actually. Rationally, I can't get my head around that one. Just check the answer, talk to your teacher. A clock is hanging on the wall with the center of the clock 3 meters above the ground. Okay, here's ones with numbers are so much easier. Here's the clock. So we know the center of the clock is 3 meters above the ground. So it all depends on the radius of this clock. So from here, center, down to here, ground, is 3 meters. Both the minute hand and the second hand are 15 centimeters long. So that's assuming those are reaching the edge of the clock. 15. Usually you do. The hour hand is 8, so it's shorter. For each hand, determine the equation of the cosine function that best describes the distance of the tip of the hand above the floor as a function of time. Okay, so that means we have to convert meters into centimeters or centimeters into meters. So we're going to turn that 3 meters into 300 centimeters. And we're going to note the clock itself has a max height of 15 if this is 0 and a low height of minus 15. But since it's 300 meters above the ground, we will determine that the high point is 315 and the low point is 285. Which means our amplitude, talking about the minute hands first, the amplitude is 15. The center is 300, so y-axis is 300. As a function of time, okay, and that t is in minutes, so how many times does it take the minute hand to go around the clock? It takes it 60 minutes, so that's the period, which means we want 2 pi over 60 or pi over 30 as our thing. Also assume time is 0 at midnight, so that means we're talking about a cos curve, that you want to start at 0, so you would put minus 15 as the amp. So you get this. And let's see if that's right. That means at the bottom here, and let's just go make this from x-axis from here, 0 to 60, and the y-axis from 0 to 333, and get rid of this. There we go. Now let's make the y-axis a little bit closer. There we go. So that means this should be at 0, and then at 60 it should be at 0 again. It should be furthest around at the ground at 30. Ah, that's interesting. Because if we're talking about the minute hand being up at 12 at the beginning, it's going to be the furthest away. So it's actually here. Let's read this question again. Assume at t0 is midnight, so the minute hand will be at the peak. So we don't flip the cos curve. So this is going to be at midnight. It's going to be 315 away. At 30, it's going to be 265 away. So that's at the 30-minute mark. And then at 60, it's going to be back up at the top. So that's a minute hand. Now, for the only difference for the hour hand, which is 8 cos pi over 30, x, is the amplitude is going to be still 300 like that. The hour hand is going to have much smaller distances traveled because it's a shorter arm. But it will still meet up with the minute hand at the 60-hour mark right there. As it turns out, they'll meet at the 45-minute mark, which makes sense as well, because that's 9 on the hour hand and 45 on the minute. And they meet up at the 15, which makes sense because that's 3 o'clock on the hour hand and 15 minutes on the minute hand. So that's a perfect replication. This just creates an amplitude of 8 for the hour hand, which is shorter, but the axis is going to be the same and the period is going to be the same. There you go. You have those two.